Hey there, Dengo Stu here. Today's video, Paul and I are going to mount this the Honda I picked up for $200 onto the green machine. The first thing we'll go through is the different transom heights and shaft lengths you get in outboard. It's really important to sort of have it so that the outboard matches your boat well. If the prop is sitting too high in the water, it'll cavitate. If it sits too low, you'll get a bit of spray and a lot of resistance, etc. So I'll show you some of the measurements that are critical for figuring out what's right for your boat. Hulls come with 3 sizes of transoms, and correspondingly so do outboards have 3 sizes of shaft length. So small is 15 inch, a large is 20, and an extra large is 25 inch. This de Havilland I've got is a 20-inch transom, so we'll just quickly measure that and confirm, and then we'll look at the outboard.
Paul's going to be executive measurer today.
It's a huge responsibility.
It is.
Okay.
So for the transom height, we're just measuring from under the keel up to the top.
520 millimetres.
So 520 millimetres, so is,
Roughly
we looked it up,
inches.
20.38 inches or something.
To measure the shaft length of an outboard, you're measuring from the anti-ventilation plate above the prop to the underside of the bracket where it hangs on the transom. So we'll have a look at this Honda. To measure the shaft length of this outboard, we're just going from the top of the anti-ventilation plate to the top of the transom. In this case, it's the underside of that bracket or the motor stand. And if we come across, it's pretty much 520 as well. So we know this is a long shaft or a 20-inch outboard, and we know we've got a 20-inch long shaft transom. So we know that we've got a long shaft motor and a 20-inch transom, so they're a good match for each other. But you don't have to mount it as it is. The modern trend is to mount motors a little bit higher, because the less of the gear case that's in the water, the less drag there is. So you start to gain an extra sort of mile an hour for every inch you raise it up after a certain speed or whatever. And that's probably important if you're looking at having a race boat or whatever, but being a commuter boat, I'm not so worried about that. There's also just less, you've got more clearance, so you don't need as much water you can travel through shallower water if the motor's mounted higher, even though you can trim it, so I'm not so worried about that either. Once you mount a motor too high, it'll start to cavitate, you'll start to suck air, and you can also start to have troubles with not getting clean water to run the cooling system as well. So although I think mounting it higher does give you some performance improvements, I think mounting it at the standard height's going to be the best sort of compromise for a run-of-the-mill commuter boat. I just want less cavitation. You know, if you mount it too high, when you turn, the outboard will kick out of the water, the leg will kick out and start to cavitate. So I really don't want to be sort of skirting that threshold. The other thing I'm really keen on is just having the bracket resting on the top of the transom. If you start mounting it 1 inch, 2 inch higher, you start needing to block this out, more of the weights on the bolts, etc. So I'm going to start by just hanging this straight on, and then we'll have a look where the bolt holes match up with the old bolt holes from the Yamaha. I'm going to start by just using the engine crane to lift this off the stand, get the stand out of the way. One other thing I should mention is that quite often transoms are reinforced with a bit of polyboard or something like that. This particular hull's been reinforced with an aftermarket 5mm aluminium plate, sort of wrapped right over the transom. So I'm going to pop this motor just straight out of the transom with a little bit of Sikaflex. We've just dropped this outboard on the transom to have a look. Because these outboards are similar sizes, a 40 and a 50, and there is a standard outboard bolt pattern, has been for a long time, and it looks like these have been drilled quite nicely and it all lines up really well. So I'm pretty happy now. This is going to be a no-brainer to bolt on. So we'll just take it off again now, and I'll start putting a bit of silicone around the holes and on the transom, and then we'll bolt it on. We've just scraped some of the old Sikaflex and sealant off the outboard bracket and the hull. So I think we're pretty much ready to go now. This time I'm using this T-Rex stuff again. First thing I'm going to do is just fill the bolt holes so they don't leak, because the 2 bottom bolt holes are either below or pretty close to the waterline. And then I'm also just going to put some silicone onto, or Sikaflex onto the bracket itself, just to dampen a bit of vibration and to insulate it.
Come forward a little. Okay, that's probably enough for now, and then just come down real easy. Okay, just hold it there for a sec. And try and do is just line this side. Just
Forward a smidge.
Yep.
Just hooked up on my side. How does that look?
It's pretty spot on this side.
To mount this, I'm going to use the bolts I took off the Yamaha that we originally had. And these are 12mm stainless steel bolts. And I'm just going to put some stainless washers on the inside and out, and I'm going to feed them from the inside to the outside. The bolts picked up quite a bit of Sikaflex on the way through, but I'm kind of happy with that because it'll also act as a bit of a Loctite. Our plan, not that we often have plans, is just to run these down a little bit, just get them snug, but not really torqued up, and then take all the weight off the crane before letting the outboard, so we can let the outboard settle before we torque them up properly.
Top right first?
Yep.
Yeah, good to go.
And bottom right.
Bottom right. Yep.
All right, should we let the crane off?
I say we let the crane off. May I?
Be my guest. Now we're just going to run the original bolts down tighter, and then we're going to run a second lock nut down each bolt just to make sure they don't come undone.
So we're going to connect up the steering now. And before we insert this rod into the engine, we're just going to give it a quick clean up with acetone.
It's got some manky old grease on it, hasn't it? I also cleaned the inside of this pivot tube when I was fixing the outboard up. I don't think I actually showed that, but we'll do a separate video on that because it's a pretty common problem if you're steering stiff, that it's old grease stuck in here. And while Paul's cleaning that up, I'll just show you this slightly rusty old can, but this white lithium grease is what I'm going to spray on the rod for the steering before I put it into the pivot tube.
Okay, pretty good.
All good?
And cue the can running out.
Yeah, I think it's empty. I think the nozzle's blocked.
Where's your compressor going?
Yeah, exactly. That's still... We're thinking the can isn't empty of grease, but it's lost all its pressure, so Paul's going to share his little trick for recharging them.
All right, a little trick when you've got a can that's run out of propellant, is you can grab yourself an old tyre inflation valve, seal it as hard as you can down across the can, and you can add yourself a little bit
At least it's coming out.
of air in theory, so you can. Oops. Alright, we might stop there before we get any more on the camera.
Thought it'll explode.
Yeah, let's see if that's made any difference.
Should give it a whirl.
Let's give it a whirl.
How's it going? Oh yeah? Okay, much better. Well done. See? Not just a pretty face.
Bravo.
So I meant not even a pretty face.
It's a bit more accurate. How much grease would you like in your beer? Alright. Alright, that looks sufficiently lubricated for your liking.
No comment.
Cool.
And as always, when you do these nuts up, make sure they're done really tight all the way. Something must be wrong. Everything's going too smoothly.
This is frighteningly efficient.
It is, yeah. Now that's torqued up to tight Newton meters. I'm going to go get a new nylock for putting the drag link on, because, as I've said before, if that comes off,
It's not pretty.
it's not pretty.
You better avoid your swimming gear.
Yeah. Now I'm going to go grab the forward controls and we'll look at bolting them up the front.
All right.
So,
So if that top bolt hole is a good guide,
so
you
we
can then
said
drill the bolts.
drill the others, yeah.
Now this is going to be your only adjustment here.
So I reckon we go as close to level as possible, just aesthetically as much as anything else.
Okay.
Just have a quick look, because that hole, feet on these, it's quite hole shape.
Yeah.
Whereas,
You'd rather use that as your
maybe,
guide.
yeah, let's try that one.
It's probably not a bad plan.
We managed to match up two of the holes to the ones that were already drilled with this plate. We're just going to do one fresh one. Alright. Now the forward control's mounted, I've just got to go and hook up these control cables to the outboard end. The wiring loom and the two control cables come in under this cover. So these are just a couple of 10mm nuts. So the longer ones are at the front. The bottom two wires here are just the leads and the battery. And then the 10 pin, or 10 actually, 12 I think it is. But the loom from the forward controls goes in the middle. And then our two control cables. What I need to do is figure out which one is throttle and which one is gear selector. So Paul just moves it. So you can see the first one that moves. So this is obviously our gear, because if you just go back to neutral, this does a distinctive move from neutral. So if you go forward, it's gone to gear. Then if you give it more throttle, it keeps moving. So we know this is throttle, then this is gear. On this outboard, the gear selector's closer to the centre of the motor, the throttle's on the outside, so I'm going to feed the throttle, so I'm going to feed the gear selector through this inboard one, and then the throttle through the outboard one. Once they're into the boat, there's a metal plate here where the grooves slot, and they're what stop the outer casing of the cables moving at all. So once that's all in, we can put this case on. Here we've got the two connectors coming in now. This is the throttle connector, comes through. I don't actually have the original fittings that this uses that didn't come with the outboard, but I've got a couple of old arc clips and just grab some washers. Alright, so I'm pretty happy with that. So just pin through washer than an arc clip, and I'll do the same thing with this throttle cable, the gear selector cable. Just winding the head on here until it falls naturally at the right distance. Now I'm going to hook the battery lead up to the battery and plug the fuel tank in. It's a bit dark, sorry, but I'm going to fire it up again, see if it still works. Actually, more importantly, last time I didn't have the forward controls connected, so I wasn't sure if the throttle and everything was working, so we'll test that. So it looks like I've got to do a bit more investigation with the impeller, the water pump, whatever. It wasn't pumping water again then, so I'll blow some more compressed air. It looks like it might have quite a bit of junk that needs moving through. But other than that, pretty happy. Thank you, sir.
Good job.
So we got a new motor. I'm still going to push on now other videos to do with finishing the electrics and that kind of stuff, but I think we'll call it a night. I think we're both tired. Time to go home. So I hope you enjoyed. Once I get this on the water, I'll let you know how this handles with that particular mounting height, but I'm pretty comfortable as a bit of default setting. It's not going to be a problem. So we'll see how it goes. Anyway, thanks a lot, and I'll catch you next time. See ya.